Okay. Hey, part 2. This is part 2 of Einstein. Hotkeys, foxes, and Einstein. Doing a cold open here. I think it's streaming. Let me see if it is or not. Alright, I think it's streaming. Yeah. Alright, this is part 2 of the stream. I noticed in the last stream at the very end, it didn't put the damn paper up there that I was talking about, which was the main point of doing it, going through that. So this is part 2. Everything said it was going out, but when I played it back, it was not there. So we're going to do it again. Here we are, 6 in the morning now. I'm up doing this damn thing. All right, I'm waiting for this computer to go there. All right, definitely. Okay, it says I'm definitely streaming now. All right, so this this is the second version of the toy model that that GTP5 came up with. This is GTP5, the thinking. They call it thinking. GTP thinking or GTP5 thinking is the official name of the model. Anyway, it may have been a different model that came up with the other one. I'm not sure what it was, but it came. It's calling this a toy model. Here, let me put it up here for you. All right, I think that's going out now live. Better be. All right. This is another version of it. I couldn't find the original one. Later on I did find it, but I couldn't find it. And so I said, okay, ChatGTP, please print that out again. You know, I just wanted them to print out the GTP5 to print out what it had done before. Instead of doing that, it just regenerated it again. And it's different, you know. Again, what it did is it took using going from 4D space-time to 2D. It's calling it a 2D topological reduction, and somehow just in a similar manner, I guess, that Kaluza Klein did, using 5D to 4D. This is going from 4D to 2D, and so it printed this out, and the key takeaway here is that the equations that it came out with are different than the equations that it did on the first one. So I'm not sure why that is. This is way above my pay grade. I don't know what it's talking about here. So what I wanted to do is just show this to folks. Maybe there's, you know, if somebody's interested in this is what it did. I mean, I'm sure there are physicists that are doing this kind of thing already. Not this exact thing. I don't know if anybody's done this before, a reduction from 4D to 2D on the event horizon of a extremal black hole. Maybe they have, I don't know. But this is one solution. Anyway, I have no idea what it did here, but it was able to somehow pull out, you know, gauge a charge quantity, a charge. Was able to get a spin, you know, everything. And then I told it to, yeah, I think I told it not to worry about Hawking radiation, but it still addressed that anyway. But I don't think there's Hawking radiation on a stable black hole that's an extremal black hole, because it's too, because it can't form Hawking radiation. You know what I'm saying? It's too small to be able to form Hawking radiation when it's that small, because Hawking radiation, if you look at the reason like why the Kashmir effect happens is because the space between the plates is small, and it's unable to produce matter-antimatter pairs for certain frequencies. The longer frequencies aren't able to form in there. And if you have an extremal black hole, it's so small that there are none that could form, right? Or it'd be so rare that it just you wouldn't have to worry about it, you know. So that was the idea, and so it went on. It talked about that, talked about masses and couplings. Hard problem number 3. I don't know what it's talking about there. Oh, this is it's referencing the previous conversation, but it's coming up with different answers. That's why I wanted to put this out here, because it came up with different equations, a different approach or whatever to doing it. Emergent Maxwell and long range fields. Low energy match. Cosmology of remnants. Jesus Christ. All right, all right, so we did. All right, here's 2. I'll go start at the top again. Okay, we get this. Doom, doom, doom. Here's doing a reduction there. I was talking about degrees of freedom. Able to get a charge, able to get spin, and then the stability, which we were just talking about. All right, masses and couplings, addressing hard problem number 3. Fuck you. God damn it, there's an ad. All right. Well, nobody's on live anyway. Everybody's going to be watching this on the VOD. So masses and couplings, okay. Then emergent Maxwell and long-range fields. So it figured out. We didn't do all didn't do all the Maxwell equations, but I'm sure it could do that if it wanted to. Cosmology of remnants. I don't even know what that's about. Worked example, the electron-like state. All right, predictions and falsifiability. This will be interesting. Discrete line, near horizon, quasi-normal mode spectrum, tied to, I don't know what that is, the A with a little hat on top of it. Spacing indirectly testable via analog gravity systems. Indirectly testable, okay. Universality of G approximately equal to 2 for all single puncture charged fermions. I was going to look that up. I saw that they use that word puncture. I don't know what that means. So I'd like to look that up too. Derivations arise only from multipuncture or higher genus sectors. So I assume these are all like math terms for higher mathematics. Charge quantization. All right. Casimir footprint. Why would it say it that way? A fixed geometry-driven contribution to the self-energy scaling. I don't know what that means either. I just told it. Before it did this, I told it, just explained to it what I just explained to you about the Casimir effect. That it shouldn't be that Hawking radiation, because of the Casimir effect, it shouldn't be able to produce Hawking radiation at those small scales. So I don't know why it said that there. Let's see, open issues and research directions. All right. So I don't know. This doesn't look like it makes a lot of sense, but I don't know that much about it, so maybe it does. But I wanted to put it out there just in case it was useful to somebody. And it's put a to-do list at the end of it. So let me go back here with it. Okay, yeah. So that's what it came up with. And I'm sure there are a lot of physicists out there right now that are doing the same thing. You know, telling ChatGPT to come up with models and slapping their name on it and printing it somewhere. You know, I'm sure that's what's going on. It's ChatGPT put his thing on there. But there it is. This is version 2.0. What it did before. And that didn't get on the last stream for some technical reasons, or whatever. I screwed up, or somebody screwed up, and it didn't show that paper. While I was explaining it, it was just showing my mug up there instead of the paper. So that was it. That was ChatGPT's toy model for quantum gravity and deriving other stuff from gravity. So, all right, I guess that was it. I wanted to get that out really quick because it wasn't in the other one, and I guess I'll put a note on the other one or I've already labeled this one part 2, so part 1 is was the first one I did, and then we'll call this part 2, and we'll do it a two-part stream. All right, that's it. Just a short little stream to put that up there, I guess. Nothing else. All right. Thank you for watching. Oh, hey, Delusion. Hi. Thank you. Welcome to chat. Yeah, this is just. I don't know. Did you catch the part 1? Yeah, did you catch part 1, Delusion? I don't know if... Oh, you didn't catch it. Okay. Yeah, what happened, the reason I'm doing this stream, yeah, you can go back and look at the VOD. It's here, it's up on YouTube. The reason I'm doing this short little stream is that during that stream, I was talking about that paper as I just did there, but the paper didn't show. The actual paper with all the equations and everything didn't show up on the stream. And so I thought, oh shit, I better do a part 2 or an addendum or whatever to my first stream to put that up there. So that's basically all this is. So that's why I just blew right through the ads too. Yeah, it happens, right? Yeah. All right. Well, I appreciate you stopping by and saying hello. You have any questions? I should certainly answer any questions you might have. If you have any. Yeah, you probably have to watch the VOD first. Yeah. Yeah, Yeah, it's kind of involved. And the VOD, the stream that I did previous, this is only one section of it. I talked about completely unrelated stuff too. You know how streamers do, right? Variety streamers. So I did that. It was part IRL and part tutorial on how to stream with OBS and a bunch of other stuff. And then this thing was kind of at the end, and I don't know. I guess I was tired and messed up somewhere along the line. Yeah, science streams are very cool. Yeah, I like doing. You might want to check out. I'm going to be doing here pretty quick. Hopefully, maybe my next stream. I don't know. I'm going to do a pretty in-depth attempt at explaining the twin paradox. There are dozens of people out there who have done it, and I just want to do my own version of it. And a lot of them have mistakes and stuff in it, and so I wanted to do my stream of it and make my own mistakes. Anyway, that's probably my next stream, is to do it. Try to attempt the twin paradox. If you're a science guy, you probably know what that is. The twin paradox is, uh, where you got twins, right? And one of them gets in a spaceship and goes out into space, traveling really fast, relativistic speeds, comes back and lands, and they're two different ages, right? And why does that happen? Uh, the paradox isn't that they're two different ages. The paradox is, why is it this twin and not this twin? Because everything is relative. You know, from this twin's perspective, this other twin and Earth and everything went away and came back, and from this twin's perspective, this twin went out. So they say, well, it's relative. Why would it be that way? And so I'll explain that. It's a pretty simple explanation, really, when it comes down to it. Let's see. Oh yeah, I don't remember. The most famous is Carl Sagan, Italian Kids on Moped. Oh yeah, from Cosmos. Yeah, I remember that. I remember him. He was he was riding around on a bicycle, I think, in that, wasn't he, and something like that. And yeah, he talked about lots of different stuff from relativity there. They did special effects, what it would look like if you were going close to the speed of light, and all kinds of stuff like that. Yeah, that was pretty cool. Yeah, he did a lot of cool stuff in there. All right, well, I'm sorry. I'm sorry you did this is such a short stream here. I just wanted to get that thing out there. Uh, I didn't even do it. I just did a cold open and everything on this. So, but I appreciate you stopping by. But yeah, if you just kind of maybe watch the schedule, maybe I'll put that one on the schedule since it's such a, I'm planning it out and all that, so I should be able to put it on the schedule. And then, but maybe it'll be my next stream. I have quite a bit more preparation to do, but I think I'll be able to do it before I do my next stream. So, all right, appreciate you stopping by, and yeah, if you're on the if you have any questions about this, if you're watching the VOD, just type them into YouTube, I guess, or you can go to doubletribble.com. But probably YouTube would probably be the best place to put that. So, all right, thank you for watching, and take care. Bye bye. Let me put my. There we go. All right, bye.